So today we're looking at exercise 6K, which is called the bisection method. Cool. Let's have a bit of a chat about what this is all about. It says here, the bisection method is a method for finding approximate solutions of equations. Cool. We can find things approximately. It says here, we restrict our attention to equations involving polynomial functions. It says with higher degree polynomials, the problem of finding exact solutions is more demanding, and it can be shown that beyond degree 4, there is no nice general formula to find all the solutions of a polynomial equation. So where we've got quadratics and cubics, there are general rules that we can use to find the solutions. So where it crosses over the x-axis, for example. Where you get higher order polynomials, no general formulas. So we need to have some kind of technique, and we don't always have access to calculators, so that can be problematic as well. So the good news is we do have what's called the bisection method to be able to get an approximate solution to these equations. So it turns out we've got the cubic function here. Perfect, x cubed plus 3x plus 6, and it says for the equation f of x equals 0, it has only one real solution. So you can see here it crosses over where the real solution is, and it is listed here. It's quite a big exact solution there. Yep. So it says here finding this by hand is beyond the requirements of this course, so you don't expect it to do this by hand to work this one out, but you could find out an approximate solution here by using this method that we're about to have the chat about, which is the bisection method. So essentially this is where you need to, this is the crux of the information here. Hopefully you can identify that it crosses over the x-axis at this point here. Yep. So when we go above this side, so let's say from when we've got, let's go, sorry, this way. When f of negative 2, at f of negative 2, you can see here the solution is going to be, it's less than 0. Yep. So it's a negative value. Yep. Is everyone cool with that, I hope? Let's try another whole number that we can easily see. When you substitute in f of negative 1, we can clearly see that the solution is greater than 1. It's a positive value. Yep. So obviously from this side here, it's going to be a positive value. Over here, it's going to be a negative value. Because it changes signs, you know that when it changes signs from negative and it goes to positive, or vice versa, that section where it changes the sign is where the solution is going to be. So if you were to have an approximation of what the solution is for this one here, y equals x cubed plus 3x plus 6, to start off with, you could, because it changes direction from here to here, you could quite comfortably say the solution is going to be between negative 2 and negative 1. It's somewhere in between negative 2 and negative 1 as an approximation. Yep, that's very, very general at the moment. But you can clearly see it is in between negative 2 and negative 1. Yep. So the whole idea of this bisection method is that what we're going to do, we're going to keep on getting these values, and what we're going to do is we're going to then calculate the midpoint of each of these. And once we've calculated the midpoint, we're then going to check to see whether it goes from negative to positive again, or the other way around, to decide whereabouts the approximation is narrowing it down. Probably better off actually having a look at this example and actually just going through it, just so that we're clear with what's going on. You can have a read of this here, which talks technically about what's going on, but I'm going to talk more generally about what's happening. Actually, we might even try drawing on it today. I've got a drawing texter. Yeah, cool, drawing works. Alright, so you could use a spreadsheet or your hand to work through this bisection method. So as you can read here, it says we first of all start off looking between negative 2 and 1, since we know that the solution lies in between this interval, between here and here. Yep. As I alluded to before, when you do f of 2, negative 2, you substitute that in to the equation, you get that the value is negative 8. Yep, and it's down here somewhere. So that's clearly less than 0. Over here, when you substitute in f of negative 1, it comes out to being about 2, yep, which is a positive value, which is greater than 0. So in this particular case, we're now going to find the mid value between each of those. So hopefully you've remembered to calculate the mid value exactly in between negative 2 and negative 1. The trick is you add them together and you divide it by 2. Yep. So we're adding them two values together, negative 2 plus negative 1, and then we're dividing that value by 2, and we get negative 1.5. Yep. So we know exactly here. That's 1.5. 1.5. This is not working so good. Anyway, that's negative 1.5, sorry. So now what we're going to do, we're going to calculate what happens when we substitute in negative 1.5 into the equation. We're going to find out f of negative 1.5. Yep. So in this case, substituting f of negative 1.5 in, we get its value is negative 1.875. So it's a negative value. Okay, so that's something that's less than 0. Okay, so in this particular case, because it's still negative at this particular point, we now know that the value, the solution is going to lie between here and this point, negative 1.5 and 1. Okay, because that was negative and that was positive. The ends were different signs. Now what we do, we keep on repeating this process to discover where this value is going to be. And you keep on doing this process as many times as you'd like to get a more and more accurate answer. So what we're going to do is we need to find the midpoint now between negative 1.5 and negative 1. So we're going to add those together and divide it by 2. And in this particular case, we get the midpoint between these is negative 1. This is not working so good. 1.25. That's in between those. So now what we need to do is find out what's happening when we do f of negative 1.25 to find out what its value is. So finding out what f of negative 1.25 is, substituting that into the equation, we get that it is 0.296875. Yep, that's a positive value. Yep, which is greater than 0. Yep. So again, we know that at this particular point, it's now a positive value, so it's above the axes here. So that means our solution is now going to be between, because this at negative 1.5 it was a negative value, and here at negative 1.25 it's a positive value, so it has to cross over that axis somewhere in between there. So it's now going to be between negative 1.5 and negative 1.25. Okay, so you keep on finding where it's crossing over. Yep, and you'll change the end points. Again, we now need to find the midpoint between negative 1.5 and negative 1.25. And you can see over the page, the process continues on. Yep. Dividing that by 2, we get the midpoint between those is negative 1.375. You substitute that into the equation, so find out f of negative 1.375, and it comes out as being negative 0.724. So that's a negative value. So this midpoint is in between these two is now negative. So it's telling you that the value has to be between negative 1.375 and negative 1.25. And so then you can keep on getting more and more accurate the more you do it. And you can see over the page, you can go crazy with your spreadsheet and keep on doing it to keep on getting a more and more accurate answer. Yep, to more and more decimal places. Even at this particular point, as an estimate, it's not too bad, but knowing that it's between negative 1.25 and negative 1.375. Yep. But you can see it's going to get more and more accurate the way we go through it. Yep. Now, today's activity is really just to get your head around this idea. Maybe just watch this video again and try and understand it. You might even try, this could be a bit of fun, loading up a spreadsheet in Microsoft Excel and actually trying to get it to do this process. Yep. There will be some thinking that's required for this, and if you haven't used Excel before, you might consider using or investigating what are called if statements if you are looking to do that, checking to see if a value when you calculate it is either positive value, so greater than 0, or if it's less than 0, and then from there, based on that if statement, you could change these values. It's an open-ended task perhaps for you today if you decide to give it a go in a spreadsheet, or you might even just decide to try having a go at it in a table. Yep. So this one here, these activities are asking for you to find approximate solutions. Whether you do set up a table and just work through it like this to get the approximate number of decimal places as an accurate answer, or whether you actually do get a spreadsheet set up, that would be really cool as well. But this is something a little bit different, just trying to get your head around it, knowing that there is another way rather than using your calculator to get these approximate solutions to these equations.